Hello everyone, welcome to Think Constructive. I am Isha. This session is specifically designed for CBSE board, class 10th student, subject artificial intelligence, subject code 417, and this is the last part of the chapter natural language processing. So part 4 I will be covering in this session. All right. If you haven't yet already seen the first 3 parts of this chapter, please go ahead and check out those sessions. I have given the links in the description box. That will be helpful for you. All right. So in part 1, part 2, part 3, I have covered all introduction of natural language processing, chatbots, their demonstrations, then text normalization techniques, all that. All right. So if you haven't yet done those sessions, I would suggest you please go ahead and check out those sessions. Links are given in the description box, and also I have captured all these 4 parts of the session in the playlist. All right. So you can just go ahead and check it out. That will be very, very helpful for you. All right. So here is the list of topics which we will be covering in this session. So this is specifically the second part of data processing. In my third session for NLP, I have done the data processing part 1, in which I discussed the details about the corpus, text normalization, all the techniques of that with the demonstration examples. So that was the part 1 of data processing. Okay, and in the part 2 of data processing, I will be covering these topics. I'll start with the bag of words algorithm. In that, I will be talking about introduction. I will be giving you the introduction of bag of words and the implementation steps with examples. Then I will talk about term frequency and inverse document frequency. In short, you already know TFIDF, right? So in short, this term you must be hearing a lot. So that TFIDF in detail I will be covering with example. So I'll start with the introduction of the topic, then term frequency, document frequency, inverse document frequency, and then we'll summarize it. All right. Then it will be followed by the applications of TFIDF and tools for that, whichever are given in your book. All right. So let us start with the bag of words algorithm. So bag of words algorithm, as the name itself indicates, many of the times the meaning of the things are hidden in the name itself. All right. So what does this name says? Bag of word algorithms. It is a bag of words. So many words will be there inside a bag, and that is where we are calling it as a bag of words algorithm. Okay, so what its definition is telling us? A bag of words is a natural language processing model or algorithm which helps in extracting features out of the text, which can be helpful in machine learning algorithm. So the whole idea of natural language processing, whatever we have already learned, is to convert human language or natural language in the computer understandable format. All right. So that means whatever we are communicating, we are talking, my machine, my system should be able to understand that. All right. So whatever I am talking, my computer will not understand as it is. So whatever the natural language or the human language, system or computer should be able to understand that. And in order to make machine understand, there should be some software, some algorithm must be running behind the scenes. Otherwise, in simple, all of you must be knowing computer only understands the language of numbers, right? And whatever we are learning in my previous sessions and whatever we are trying to do in this session, ultimate goal is to convert the natural language or the human language to the numbers so that computer can understand that. So in my previous session, I told you about text normalization, but still there also text was simplified, but text was not at all converted to the numbers. So that was just the intermediate step. Okay, so the next step is to do something extra, some more steps, some more processing so that computer can actually convert the text or the textual language to the numbers finally. That is the ultimate goal. Okay, so whatever steps I am telling you here, the goal is to reach to the numerical conversion of the textual data. Okay, so that's what. So bag of words is one algorithm or one more intermediate step to achieve that goal. Okay, so in bag of words, what is happening? The entire textual data, or if you remember the corpus, will be broken down into pieces, and finally a bag will be created in which so many words will reside. Okay, so what is the outcome? A vocabulary of words for the corpus. I hope all of you remember corpus. Okay, I'll just tell you in one line if you don't remember. But I would still suggest, if you haven't yet watched the session 3, please go ahead and check. All these things I have already explained there in detail with examples. So what is a corpus? It is a collection of document or collection of textual files in a directory. Okay, so many documents will reside in one directory, or so many textual files will be collected at one place, and that is called as corpus. Okay, and the frequency of the words. So frequency is what? Count. Okay, so the frequency. So number one, what is the outcome? Vocabulary of the words from the corpus, and then the counting of each word from the corpus. Okay, so frequency is nothing but the counting. Okay, I hope this is clear. So I'll move from this step. So here is the example of bag of words. Okay, so first we'll have a look at this and we'll understand, then we'll move from here. Okay. So you can see here is a corpus or a big textual data is given. Okay. And what is the outcome of bag of words? The vocabulary of words from the corpus. So let's say this is my corpus. Okay. And vocabulary will be taken from this, filled in a bag like this, and then counting or frequency of each word will be depicted here. So corpus is converted to the bag, to the vocabulary or to the words. Let us assume filled in a bag like this. Okay. And then further, this vocabulary's frequency or counting is available like this. All right. Okay. So let's take the example of times word. So times word in the corpus is here, one place only. And then in the bag of word, I can see times is given here. Okay. And here in the frequency, you can see the frequency of times is given as 1. Okay. Likewise, you can pick up any words example from here. Let's say this, and then try to find out here and see the frequency here. All right. So I hope this part is clear. Okay. So we'll move from here. So here are the implementation steps of bag of words algorithm. First step is text normalization. So this step I have already covered in my session 3 in really a great detail with all the examples. So I would again suggest, if you haven't yet seen that, please go ahead and see session 3, where you will be able to understand text normalization in detail with examples. Okay. For now, I will just tell you the purpose of text normalization is to take the data or data as an input as corpus, pre-process it and convert the data after each and every text normalization step to the separate tokens or words. Okay, but there are more to it. So please go ahead and have a look at that. Okay. Next is create dictionary. Then I will talk about create document vectors. And then the last step of bag of words algorithm is create document vectors for all the documents. Okay. So let us move to the first step, example. So the first step is text normalization, as I said. So I am just taking an example here so that we can connect all the dots later. Okay. But text normalization steps explanation, I would again suggest you should know. And for that, go ahead and see session 3. Link is given in the description box below. All right. So data collection and pre-processing is called as text normalization in a very, very simple terms, if I say. So the example I have taken is document, 3 documents I am taking for a corpus. Okay. So all 3 are forming a corpus. So all 3 are forming a corpus. So I have 3 documents for my example here. 1, 2, 3. All right. So document 1, Aman and Anil are stressed. And document 1 after text normalization will be converted like this. So for document 1, you can see all the words are taken as a separate token in the lower case. Aman and Anil are stressed. All right. Similarly, for document 2, the words are converted to small case and treated as a separate token. And similarly for document 3, like this. Okay. So after normalization, we get this. All right. So again, probably I'm repeating, but go ahead, check out session 3, learn text normalization properly and come back here. Then you will be able to connect everything and understand everything. All right. So if you notice in this example, and, are, to, these kind of words we talked about earlier are called as stop words and should be removed. But since in our example, this corpus itself is very, very small. All right, I have not taken any very big paragraph or two big documents. So my corpus is already very small. So these words we are not removing after text normalization also, because they might carry some good value to our textual data. Okay. So since it is very small, they will also have equal or good weightage. So we are not removing. Otherwise, we would have removed them while doing or while normalizing the text. Okay. I hope this is clear. So we'll move from here. Second step of bag of word algorithm is creating dictionary. So what is dictionary? In terms of NLP, not a generic kind of dictionary I'm talking about. Okay. So in NLP, what is dictionary? Dictionary means the list of all unique word that is coming in my corpus. All right. So we started from corpus. Corpus was the core input data, and from there we normalize the text, and now the next thing we are creating the dictionary. So in my text normalization process, what I have got? The list of all the tokens. All right. So now, or simple terms, you can say all the words. So this list of words or tokens should be recorded as a unique word or one word for each. Okay, and that will be termed as dictionary. So list of all the unique words occurring in the corpus. And notice the important point. If some words are repeated in different documents, they will be only written once, because what I am saying, list of unique word in the entire corpus. Okay, so that will form or give me a dictionary. All right, take all the words retrieved after text normalization. This is what we talked about, and then list down unique word. That will give me the output as dictionary. All right, clear. So I'll just show you the example. From the corpus, we started with 3 documents, normalized output we have got, and now what we have got from that normalized output or from that list of words, the dictionary. Each word is written only once. See? So if you remember, in my original corpus, let's take example of Anil. Okay. Anil was coming more than once. See? In this, document 1 has Anil and document 3 also has Anil, right? Correct. But in my dictionary, I have only written Anil once. Okay. So this is what I meant was list of unique words. Every word should be written only once. Okay. So my dictionary is ready. Now the next step, create document vector. So for creating document vector, or what do we actually mean by document vector, isn't it? So it will be the table of unique words which we have got from the dictionary, and then the counting of each word in the document. The output of that is called as document vector. That means first thing, for creating document vector, what should I do? Let us learn that first. Okay, I will create a table. And what will this table do? In that table, I will write unique words retrieved from create dictionary process. Okay. So this is the list of unique word. These all words I will write in top row of the table. I will create a table and fill its header row or top row with all these words which we have got from the create dictionary process. Okay. This is what my first point is. Now, the second row of the table should contain the counting or the frequency of each word in the document. Got it? Okay. So, for example, Aman. In document 1, I'll show you. In document 1, Aman is coming only once. Okay. So, when we create document vector for document 1, the frequency for Aman will be 1. Okay. So now what is the algorithm or a simple steps for creating document vector? These 2 steps are clear. Well, first thing, we'll create the table. Top row or header row will be the list of words given by the dictionary, and second row should contain counting of each word in the document. So I'll elaborate this a little more. So these are the steps which are written. For each word in the document, what am I supposed to do? If it matches with the vocabulary, put a 1 under it. Okay. If the same word appears again, like Aman, I had taken an example. So in document 1, let us assume if Aman is coming 2 times. So for first time I will write 1, and second time I will increment the value of Aman by 1. That means it will become 2. Okay. And if word does not occur in that document, because I am getting a list of unique word, so that word might be present in document 1 but might not present in document 2 or in other documents. All right. So if word does not occur in the document, put a 0 under it. Okay. I hope this is clear. I'll show you the example now. You'll be able to relate it better. So example of this, for document 1, I'm creating document vector now. Okay. So for document 1, Aman is coming only once and is coming 1. Okay. Anil is coming 1. R 1. Stressed 1. Aman and Anil are stressed. That was my document 1. And all these are coming only once in that. Other tokens or other words, went, download, health, chatbot, therapist, A2. All these are not at all coming in document 1. So under this, I have just kept as 0. All right. Okay. So this is my third step. I hope it is very clear now. We'll move from here. What is my last step? Create document vector for all the documents. Similar process. Similar process, what I meant was what we just talked about. The third part of bag of word algorithm, create document vector. So this step I should be repeating for all the documents, but in the same table. In create document vector, I had created one table with document 1. Same table I will be continuing for document 2 and 3 also. Okay. So that means repeat create dictionary process for all the document. Okay. Header row contains the vocabulary of the corpus. Same thing. Okay. And then subsequent rows containing the counting of each word from respective document. All right. So same 3 steps are written here. And then, so this is the example for document 1, 2 and 3. That means all 3 documents of my corpus. So document 1, we had already discussed. All right. Document 2, Aman was coming only once. Went was coming once. Therapist was once. Once, 2 once. So what was document 2? Aman went to a therapist. Okay. Aman went to a therapist once. And every other word is 0. Because they are not at all occurring in document 2. Similarly for document 3. Okay. So this complete thing is now called as document vector table. And this is what the outcome of my bag of words algorithm, which is called as document vector table. Okay. So outcome of the bag of word algorithm is document vector table. And what is my document vector table? We have just now seen. All right. So document vector of all the document is called document vector table. It contains frequency, that means counting of each word of vocabulary in each document. So with this we have executed all the steps of bag of words algorithm. Can we say now my tokens are converted into numbers? Not yet. Correct? So that means there is something more we should be doing to reach to that level. All right. So more to data processing, more to process data. Okay. So we'll move from here. So now the next step or next part of this session is term frequency and inverse document frequency. In short, TFIDF. All right. In short, we call it TFIDF, term frequency and inverse document frequency. It mainly contains 2 parts. Its name itself tell you, right? One is term frequency and another one is inverse document frequency. In short, we call it as TF and IDF. So TF plus IDF is TFIDF. Okay, like this we can say. And this is the final step of converting tokens into numbers. So till previous step, we had tokens with their frequencies in a table format. Okay, and now we'll be taking that as input for TFIDF and convert that inputted token document vector table to numbers. All right. And why am I doing it? Isn't it? First agenda is to convert everything into numbers, and then also TFIDF helps in identifying the value or the weightage of each words. Okay, how much value that particular word have for that corpus which is being processed. Okay, so the corpus which is being processed to reach to the numerical level, what is the value of each word in that corpus? Okay, I hope this is clear now. Also, if you want to ask questions or if you have any doubts, you can write your queries in comment section. Okay, I'll try to answer you as soon as possible. All right. So this is one graph which is given in your book. It shows the relation between occurrence and value. Okay. So what happens is, when we say, we always remove stop words. Why? Because their occurrence is very, very high, you see. And the word which is coming in my corpus in multiple documents, multiple times, that means that word doesn't carry much value. Why? Because it's getting continuously repeated, and those words are termed as stop words, and that is where we end up in removing them, because it is only just flooding my data, nothing else. Okay, and then you can see the words which are less in occurrence but their value is very high, and those are called as rare or valuable words. Why? Because they come very rarely. Like in our example, if you notice therapist, that is one word which is coming only once, but therapist carry a significant value in that corpus, because someone who is not feeling well or having some issues, they are going to contact therapist. So therapist contains a significant amount of value, so that word becomes very valuable, and that comes rare, because in corpus I cannot keep on talking about therapist like that, right? It will come less or rarely, its counting will be less, but those will be valuable words. And then the frequent word, they will have kind of value as average value, and their occurrence will be somewhere in mid. Those are called as frequent words. All right. Okay, so let us move from here. And then what do we understand from TF-IDF? It is clear, it is a combination of TF plus IDF. Okay. So first thing we'll see, what is TF or term frequency. Frequency of each word in one document. Each word in one document. Okay. We have understood this thing till now, isn't it? Can be found from document vector table. You remember what is document vector table? The output of my bag of word algorithm. The table in which the frequency of each unique word was captured for each and every document separately. That was my document vector table. Okay. So term frequency can be found in this. Frequency of each word in one document. Okay. This is nothing but my document vector table. Remember, right? So in document 1, I can see the frequency of Aman and Anil are stressed. Okay. In document 2, I can see the frequency of Aman and 0, Anil 0, R 0, stress 0, vent 1, like that. Alright. Similarly for document 3. So for each and every word, I can find the frequency for each and every word in separate document. Okay. So this is what my term frequency is. Now the next part of TF-IDF is IDF. But before learning IDF, let us understand what is my document frequency. Then we'll come back to this. Okay. So document frequency is nothing but the number of documents in which the particular word occurs. Okay. I'll come back to next line, but first thing, number of documents in which the word occurs is called document frequency. That means in document, we are taking an example of 3 documents, document 1, 2 and 3. Aman is coming in how many documents? 2, right? See, Aman is coming in document 1 as well as in document 2 also. Okay. So frequency is 2. I would rather say document frequency is 2. And is coming only in one document. And is coming only in document 1, not in 2 and 3. So its document frequency is 1. Similarly, Anil is coming in 2 documents. So its frequency is 2. Likewise, you can see for others. So the important point for document frequency to understand is the word occurs in how many documents or in the number of documents. That counting is called as document frequency. And it does not matter how many times that word occurs in particular document. Okay? Clear? So it doesn't matter how many times that word occurs in particular document. It doesn't matter for document frequency. What matters is in how many documents that word occurs. Like Aman occurred in 2 documents. So its document frequency is 2. And occurred in only 1 document. So document frequency is 1. Okay. So I hope this point is clear. We'll move from this slide. So now after understanding document frequency, we can inverse that, right? And call it as inverse document frequency, that is IDF. We need to reverse the document frequency. We need to inverse that and call it as inverse document frequency. So what is the formula for that? Inverse document frequency. Inverse document frequency is the total number of documents divided by document frequency. Alright. So in our example, how many documents do we have? 3. So for Aman, total number of documents are 3 divided by document frequency for Aman was 2. So 3 divided by 2 is the inverse document frequency for Aman. Similarly for and, total number of documents would remain same for all, right? Correct? Because these are the list of words from all the documents. So total number of documents would remain same, right? 3, 3, 3, 3 everywhere. In all the words you can see. But those will be divided by document frequency, and document frequency for each word may be different, may vary. Alright. So for and, it is 3 divided by 1. See? Anil, 3 divided by 2 and so on. Okay. So that's how we calculate inverse document frequency or IDF. Okay. Remember this formula. This counting total number of documents would remain same for a corpus, but document frequency may vary. Okay. So this takes us to the final thing, that is TFIDF, document frequency and inverse document frequency, right? Which is the topic we are discussing now. So it is a combination of TFIDF, is a combination of term frequency and inverse document frequency. Okay, and we will first understand that from this formula. For any word W, term frequency inverse document frequency is equal to term frequency for that word multiplied by log of inverse document frequency for that particular word. Okay, I'll repeat. How the TFIDF will be calculated for every word, because it is always calculated for each and every word. Okay, so how will that be calculated? Term frequency for that word multiplied by log of inverse document frequency for that word particularly, and log is generally taken as a log base 10. Okay, so this is how it will be calculated, because ultimately we have broken down corpus into separate tokens, and now we are calculating the value of those tokens. Okay, so that computer can finally understand the language of numbers. This is what we are trying to achieve. So now we'll go back to our important points. What TF-IDF does, it helps in identifying the value of each word. This is what we are discussing, right? TF-IDF will give me finally the value or the weight of each word for a particular corpus. And term frequency inverse document frequency, what is it? It is a numerical, it starts, right? This is what we are learning till now. That is intended to reflect how important a word is to a document in a collection or corpus. Correct? This is what we have discussed till now. What are we trying to achieve? The weightage or the value of that word for a particular corpus or collection. And it is defined in terms of numbers. Okay? So we'll move now towards the example. So you remember our document vector table. Okay, then we calculated the IDF, we saw TF, we saw IDF, and now we are seeing the combined thing, TF, IDF. So this was a table which we were discussing. For document ID 1, let's take Aman is a word. What was the Aman's term frequency? For document 1, it was 1 only, multiplied by log of 3 by 2 or log of IDF. Okay, then AND frequency of AND, term frequency of AND was 1 and IDF for AND was 3. So 1 into log of 3. Similarly for Anil, term frequency was 1 and IDF was 3 by 2. So log of 1 into log of 3 by 2. Right? So that's how you will put the values for each word given in every document. All right. So that's how you fill this table. Okay. So that's how you will fill this table till here. Okay. And then we'll move and see what next. So finally, after giving the log values, you'll get the resultant like this. Okay. So in case of Aman, if you remember, 1 into log 3 by 2. So log 3 by 2 is 0.176. So 1 into that is this. Okay. Likewise, in case of AND, 1 into log 3. So 1 into log 3. I mean log 3's value is 0.477 into 1. So it will be like this. Okay. So after reaching till here in this table, if you notice, let's say we take the high value, which is in this table is 0.477. So download. It is a high value word, health, chatbot, like this. Okay. So from this table, you can identify the words which are carrying more weightage or more value are called as valuable words. And finally, also you can notice the tokens are converted into numbers, and numbers are understandable by machines. Okay. So now there are some key points or summary for TFIDF. So first point is words that occur in all the documents with high term frequency have the least values and are considered to be stop words, right? This is what I have explained you from the graph. If you remember the top portion of that graph, let me just draw a small graph here. The graph was like this. Here we saw the stop words and here we saw the value words. Now you remember? So what is it talking about? Words that occur in all the documents, they will have high term frequency obviously, right? But they will carry the least value and are considered to be stop words. Okay. Next point is for a word that have high TF-IDF value. That word needs to have high term frequency but less document frequency. Can you think of why less document frequency? Because for TF-IDF formula, if you remember, what was the formula? TF into log of IDF. Okay. And IDF, what was IDF? IDF is total number of documents divided by document frequency. Now you can relate, but less document frequency, which shows the word is important for one document but is not a common word for all the documents. All right. And then the third point is these values help computer understand which words are to be considered while processing the natural language. The higher the value, the more important the word is for the given corpus. So ultimate goal was to convert the language to numbers or tokens to numbers. Okay. And then to identify the higher value or the higher weightage word for the particular corpus. Okay. So everything is happening for corpus. Okay. So for corpus, what is the high value word? That can be identified with the help of TF-IDF. And once the value or the valuable word is identified, computer will know that which word to be considered for processing the natural or human language. All right. So I hope these 3 points are clear. I would suggest you read or you focus on this explanation and slide multiple times. What next I'll be talking about is the applications of TF-IDF. So now TF-IDF is clear, right? Human language is converted to numerical or the language of numbers, which computer will understand, and in addition to that, computer will now also know that which words are more valuable for a corpus to be processed as a natural language. All right. So this was the agenda when we started with NLP and we reached till here. Okay. So what are the application areas of TF-IDF? Document classification. This is anyways the application of natural language processing. I talked about all this in session 1. Right? Helps in classifying the type and genre of the document or the category of the document. So document classification was the one application which we discussed, if you remember. So what TF-IDF does is it helps when it will give the most valuable word to the computer. It will know what is the kind of this document is, what is the category of this document is, what is the genre of this document is. All right. So it helps in document classification. Another point is topic modeling. It helps in predicting the topic for a corpus. Again, the same thing. When it will know which kind of words are the rare or the most valuable words for a corpus, then machine will know that what kind of topic it will fall into. So topic modeling will happen here. It will be able to tell what kind of topics this particular corpus should fall into, should go. Alright, so topic modeling it will do. Now, the next thing is information retrieval system. Again, the similar thing. See, to extract the important information out of a corpus. How? Because you are getting the most valuable word. That means you are extracting the most important information from the corpus. Not you, the machine. Alright. So, the machine will be able to extract finally the most important information from the corpus and helps in retrieving the crux or the important things or the important information from the system, from the corpus. All right. And then a stop word filtering. I kept on talking about this, right? So helps in removing the unnecessary words out of a text body. That means unnecessary words are called as stop words. So it helps in removing them out and let machine focus on the important information which will help in processing the language and understanding the meaning of the corpus by the system. Okay. So these are the important application areas. Alright, so every application area, if you'll focus, talks about the valuable words only, and that's what the idea of TFIDF. Alright, so I hope this thing is very, very clear now. Just to summarize what all we have covered in this session, we started with bag of word algorithm, all the implementation steps of that, starting with text normalization, which I have already covered in session 3. Link is given in the description box. Please go ahead and check that if you haven't yet attended that. Okay. Then we created dictionary, followed by creating document vector for one document and then for all the documents. Okay. And the outcome of bag of word algorithm was document vector table. Okay. That document vector table is taken as an input for TFIDF. So TFIDF is the combination of term frequency and inverse document frequency. We covered term frequency. Then for understanding inverse document frequency, we first covered document frequency and then inverse document frequency, their calculations, their examples, followed by the TFIDF applications. All right. So there are some tools given in your book for covering all these steps. These steps are essentially the steps of text normalization. So if you take some example, any random paragraph or some collection of textual documents and want to convert them into or want to normalize the text, you can do that manually and then check your answers with the help of these tools. Okay. And this will help you to just verify all your answers. Okay. And here comes the end of this chapter, natural language processing. So this was the fourth part of the final part of this chapter, which I have made. I have already created the playlist of natural language processing chapter. All 4 parts are tagged in that playlist. You can either refer to that playlist or all remaining 3-part links also I have given in the description box. So if you haven't yet seen those part 1, 2 and 3, go ahead, see that and understand natural language processing in the detailed great depth with all the examples I have done, I've covered. Go ahead, learn this chapter. All right. Share this with more and more people so that more people will get benefit out of this. If you like the session, hit the like button, ring notification bell and subscribe to my YouTube channel, because I'll continuously bringing you more and more useful sessions, useful chapters for your learning and for others also. So please don't restrict yourself. Share this with many other people so that everyone can, join the sessions and learn and you also learn. So hit the notification button, don't miss it out. Otherwise you will miss out on the next upcoming videos and next upcoming lectures, which might be very beneficial for you and for everyone else. So share, subscribe and like if you liked it really. Leave your thoughts in the comments. That will be very helpful for me. So we have reached till here. Last but not the least, thank you so much for watching the session. All right, and stay connected with Think Constructive so that you get more and more educational videos, more and more sessions, and we'll love to see you back again in my next session. Thank you once again. Bye bye.